Still very snowy outside.
I'm okay. I'm a little tired. How are you, Emil?
I'm good. I
Yeah.
am also tired. And I'm already falling behind my schoolwork, but
That's okay.
that's a tomorrow problem.
Yeah. Are you going to share your screen?
Oh, am I not sharing my screen?
No, not yet.
This
No,
is
not
awkward.
yet.
I was just looking at the
That's okay.
slides being like, okay, here we go.
Awesome. Cool. Okay. Well, thank you everybody for joining. I know that this is a pretty hot topic with Git and GitHub. So hopefully you can sort of learn a thing or two, get a little bit more comfortable with Git and GitHub. Yeah, we can start. Awesome. So my name is Gavin. I'm the GDSC lead for Conestoga College. Yeah. Emil?
Yeah, and I'm Emil. I am not the lead, but I am an executive member or a tech lead, as it's written there. And yeah, I'm glad to be part of this. So
Awesome. So for today, we are going to briefly get you to start downloading Git if you haven't already. And if you haven't also already made like a GitHub account as well. While that's sort of downloading, we'll talk about the importance of Git, why we need to learn it, about and just some basic sort of concepts from it. And then we'll get into more of the commands and topics like branches and conflicts, which beginners really struggle with. And then we'll sort of end off with some tools, any Q&As if anybody has questions, and then we also have a raffle. So make sure you stay till the end. We'll also have a little bit of demonstration going along too. You're more than welcome to create your own repo and sort of play around and follow Emil when he's doing the demonstration, or you can just sit back and relax and sort of just take it in. Awesome. Yeah. So this is the download link. If you have not done this already.
yeah.
So you can go here and download it. It's a pretty easy installation. You really only need to click next a bunch of times. You don't need to like play around with the settings or anything. Yeah, and when you first open up Git Bash, which is like the command prompt, you may have to, thank you, you may have to adjust some of your settings. And you can do this using this git config -- global user.name. You can also just like Google Google this too. It's a very like starter or beginner thing as well. I also have a link here for first time setup as well. That's important. Awesome. So while that's downloading, we will continue talking. Cool. So why learn Git? It is a very popular tool for software collaboration. It is used pretty much everywhere. And one of the big reasons to learn Git is to be able to go back on your mistakes. That's sort of reason number one. So if you code something and you implement something new, but it turns out it doesn't work or it breaks something, you can actually go back in time and select a different snapshot of your code. And that is a really powerful process there. Traceability too. So you get to actually see how your code is progressing. You can see, who's added code, who's removed code. And that, again, is a really powerful tool. Another big thing is, again, like the collaboration. And many companies, like almost every single company, probably uses Git in some way. Yeah, and it's also a very increasingly popular infrastructure management. And Emil can share some insight on that as well.
Sure. Yeah. So and some of you might be in like an IT field, or even me in a CS program, right? We've taken some courses that talk a little bit about like IT sort of stuff. And the big trend right now in IT and infrastructure management is a thing called infrastructure as code, which is a very fancy way of describing a way of like modeling your like virtual machines or something as text files. So if you hear ISC or something like that, that's basically what it is. It's just using lots of text files. So if you look at a lot of like infrastructure or like DevOps or like IT management tools, I listed a few there, like Ansible or Terraform or even Kubernetes. What you'll see is that they all use configuration files, like just plain text files. Um, and the reason why they choose to do so is because of Git, and it's because you can, for example, with Terraform, you can describe all of the virtual machines that you want to be created or just deleted or whatever. And as text files, they can be managed with Git. And say you are launching a few virtual machines, and the first thing is that everyone can kind of see that, right? Like there's a lot of traceability, and they say, oh, this is the person who's launching these virtual machines. And above and beyond that, you can like go back in time, you can kind of like review your changes, that kind of stuff. So Git's very popular in software development, but it's kind of like pervading or taking over basically all of like technology and IT.
Yeah, awesome. Thank you. Yeah, so the actual definition of Git, it's a version control system, or VCS. So it allows you to do distributed or decentralized version control. And really all that means is, are you pushing your code or saving your code to like a cloud or another system? Or is it sort of distributed along a bunch of different like repositories or computers? It allows multiple developers to collaborate on the same project at the same time with minimal interference with each other. And we'll get into this a little bit later. But if you take a peek just at the picture here, we have our master, our main branch, and two features. So a big part of Git is being able for me and Emil to work on the same set of code, but doing separate things in case our code conflicts, or we're doing two different services, and we don't want to like break each other's code at the same time. So that it's a very powerful sort of mechanism there. And again, we can travel back in time to other versions of code. Looking at the picture again, you can see those dots, and those dots would probably symbolize commits or snapshots of your code. Or like you can think about it as like a game save file. If you save it on multiple saving slots, same thing here is you can go back and get your previous load or get your previous snapshot of code, that sort of thing. And for branches, we can branch off of different commits, do our own separate thing, and then push that code back onto the main branch there. We'll get into more detail as we go along here. But yeah. Awesome. So the main concepts, especially for beginners and pretty much how you're going to spend like 90% of your time using Git, is using these like 5 commands. So a commit is a snapshot of your code. Think of it again as like a saved file, like in a game. And your repository is the storage location of your project. You technically have, when you're using Git and GitHub, you have 2 repositories. You have your local and you have your remote. And so when we are in the working directory, which is where we're coding, our file, if you have like a VSCode pulled up and you have your index.html and that sort of thing, and you're working away, that there is our working directory. Typing git add and the name of the file or like a period will add the current state of your files if they're modified, added, or deleted into the staging area, where it's like a not quite saved officially, but it's in the area where the changes won't necessarily affect that snapshot that you're going to change. Yeah, you can use git commit to finally say, okay, I want to save this snapshot of code. And that gets pushed into your local repository. And your local repository stays on your machine. Using git push, we'll push it to a remote repository. In this case, like we're going to be talking a lot about GitHub. Yeah, and then that way anybody can actually access your code and pull it or make some changes or do their modifications or whatnot. When you do have new code in your repository, but you have old code on your computer, you can use git pull, and that will update your repository with the repository that's online. You can sort of think about this as like a OneDrive sync. If you have an old version of a Word document on your computer, but OneDrive has a newer version, you're going to like download or click and drag or something to get that onto your machine. The same sort of concept here. Now, git reset is a little bit different from the other ones. It is when you have something saved, but not yet committed, and you want to move back from the staging area back to your working directory. And this is helpful if like you forgot to add a line of code before you commit, or if you accidentally didn't comment or commented something out that is going to break the commit. You can use git reset. It pushes it back into the working directory. You can go ahead and make the changes and go through that process again. Yeah. Awesome. We're going to run through these commands, and then Emil is going to jump over and show y'all these commands in action. And I will send this cheat sheet in the chat here. But firstly, git clone is the way to get the GitHub repository onto your computer. It's essentially downloading it. Git remote at origin with the repo link will actually set the origin or where you want to push to. It's a little bit more advanced, but we wanted to include it in here because you might run into this issue here and there when you're working on your own stuff. And again, this says, okay, this repository that's on my computer, I'm going to push that onto GitHub or Bitbucket or another tool somewhere else. Yeah. Git init initializes the repo or like locally. And this is pretty much like step one, other than downloading Git, anytime that you're making that repository or installing Git onto a directory. Git add with the file name adds files from the working directory into your staging area. Most oftentimes, like for me, I use git add with a period, and that adds all the files that have been like deleted or modified or added. Git status allows you to check if the files are staged, which ones aren't, which ones aren't even being tracked by Git. It's a really helpful tool to know like exactly where you are in the process. Git commit, which you've probably heard a bunch before, allows you to take that snapshot of code that's from the staging area and say, yes, I want to officially make this a save file in your local repo. Most times you'll do like git commit -m and write a little comment saying like bug fixed or something like that. Yeah. Git push pushes from your local repo to your remote one that's on GitHub. And git pull gets the code from the remote repo back onto your local machine here. Awesome. If there's any questions too, feel free to put them in the Q&A chat. I opened up a Q&A chat there. And at the end, we will try and answer as many as we can. Yeah, awesome. Emil can take it away.
Sure. So I will just move over to a Windows machine that I have going on here. It looks a little weird with 4 windows, but basically what you can see down here is on the bottom, we have 2 Git bashes. I'll actually minimize these for now. Later, we'll simulate kind of 2 people working on the same project. So at the bottom here, I have Git Bash open. I've kind of already opened it to a folder. The thing to know about Git Bash, so Bash here, is it uses a thing called Bash. You might think that sounds like Linux or Mac, and you're right. So it's basically like a terminal that takes in Bash commands, so like cd and whatever. So if you see me like type in some commands, they're not technically part of Git, or some of them might not be part of Git, but if you look up like Git Bash tutorial or reference sheet, then you will most certainly find some good resources. What I'll start off with is git init. So here I have right now I have my Git Bash opened up to this folder called source, and I actually have it opened up here too for more visual representation. So I'll first show off Git init. So if I type in Git init and then a name like my first repo, and then I enter. Repo is just a short form people often will use to refer to repository because CS is full of slang, I guess. And you can see that what it's done is it's initialized an empty Git repository at this blah, 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 blah. And you can see up here, my first repo has popped up. And if I open this, I actually have hidden files, hidden items visible. And you can see that Git actually created this tiny little folder called .git. You might remember Gavin talking about a local repository, like how it's decentralized. So like basically everyone has their own local repository that like syncs up with the GitHub or whatever. That's this folder. So little fun fact there. So if say you mess up your Git royally and you want to just start over, but like keep the actual like source code files, you could just delete this whole folder and then it's as if it's just a folder full of files and it's not a Git repository anymore. So that's Git init. What I'll go to is I'll open up this folder here. So we'll drop this in the chat, this repository, but basically this is GitHub and this is like a remote repository. And so I'll go ahead and clone it. And I'll just show off some of the other commands with cloning. So to clone on GitHub, there's a lot of different ways. I suggest just sticking with this. And then basically you want to run git clone and then copy and paste this thing in. So I'll go ahead and copy it. I'll go back to here and then I'll type in git clone. And here is a thing that I honestly found out yesterday. To paste in Git Bash, you can't use Control V. I believe it's Shift Insert, but what I do is I just right click and then I click paste. Yes, it is Shift Insert. So if you're hitting Control V and it's not working, that is why. And that is a bit of a panic I had yesterday. So anyways, I'll type that in and I'll click enter. And you can see it's saying it's cloning into this. And it's talking about basically all of the work it's doing, like receiving objects, whatever. But more importantly, you can see that there's a new folder here. And that's the same repository as what was on GitHub. So if I open this up, you can see that one, we have the .git folder because it's a Git repository. And we have this data file, which if I go back here, you can see that the data file here. And I'll just click on it to show that it says hello world there. And if I go back here, and if I was to open up this text file, you can see it's the same content. So that's great. But we're more interested in like doing stuff with this text file. So say I want to modify this text file. Maybe I want to say, instead of hello world with a period, I want to say hello world with quite a few exclamation points. So what I can do is I can just modify the text file and then I can click save. And so far, Git hasn't done anything. I've just modified this text file. However, if I type in git status, first thing I need to do is I need to be in the right folder. So I'm still in my source folder. So what I actually need to do is type in cd and then git. And I basically want to open this folder here. A pro tip with Bash and with Git Bash, if you hit tab, it'll try to autocomplete for you. So cd is changing the folder I'm in, and then Git and GitHub, blah, 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 is the folder I want to go to. And you can see I'm now in that folder, and Git Bash is actually pretty smart. It says, oh, you're in a Git repository. I'll say that I'll figure out what branch you're on. We'll talk about branches later. But the important thing to know now is that with this blue text here, that basically means that we're in a repository. So anyways, I can type in git status again. And instead of just complaining at me, Git is going to say that there are some changes and they haven't been saved. So basically, it knows that I've modified this data file, right? And if I go back to GitHub, nothing has changed here. I've only changed it on my local computer. So I can just use the commands that we talked about. So the first one I want to use is git add, and then I want to type in the data file. Again, I'm using tab to autocomplete, and nothing happened. However, if I was to type in git status again, you can see that instead of it being in red and saying that it's not staged, you could say that it now knows to say that it is staged, right? It changes to be committed. And so now I can commit. So I'll type in git commit. Now, the one thing you should know is that all commits should contain a like message. So basically like as one sentence or a couple lines description of what this change is about. And you can do so kind of with a shorthand using -m and then quotation marks. And then inside the quotation marks is the message you want to say. So here I'm saying git commit -m, and I'm saying that I changed periods to exclamation points. I know how to spell. And then I can click enter, or hit enter, and you can see that it just summarizes. Git often will just heavily summarize what you're doing. And so you can see that's one file change, it's that one, and we're great. However, these changes are still not on GitHub. To push these changes to GitHub, I have to use git push. If I use that, you can see that it's blah, 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 and you can see that it's going to this GitHub address. And so just as a last thing to show off, if I go back here, and if I just refresh this page, you can see that it says hello world. And GitHub also provides a lot of information. So you can see that my git commit message is up there too. And yeah, that's just about it for now. I will pass it over to Gavin to continue on.
Awesome. Thank you. There's a quick little message here in the chat. Is there a limit of characters for the message? Do you know off the top of your head, Emil? I think it's like 200 or so, like 150,
Yes.
something like that.
Yeah, I do believe it is configurable, but I
Oh, okay.
think most like GitHub and like maybe the default is probably like 200-ish
Yeah, something like
characters.
that. You can on GitHub, when you push something, or if you're doing something in GitHub, you're able to like have a title and then have a description of things. I don't know how to do that like locally on your machine, but like if you need to like really type something out, you can do it there, or opening an issue, and that's more of like an advanced topic. Hopefully, we'll cover that in like part 2 of this like Git and GitHub workshop. But yeah.
Yeah. I'll just say like as a rule of thumb, like the shorter the better. Like obviously you want to have enough information that you like can look
It's
at it and
clear.
know what's going on,
Yeah.
but you don't want to just you know, and then part of it is you want to commit often so that if you commit often, your messages will be smaller because hopefully your changes are smaller kind of thing. But yeah, very good question.
Yeah. Awesome. I'm just about to answer the new question. Which one is in the branch, main or master? Yeah, give me 1 second. I will sort of explain that as well. Yeah, so with Git branches, so Git repositories usually have a main branch or like a parent branch, often referred to main. It was deprecated maybe 2 years ago to get rid of the term master. So you might see master sometimes. You might hear it referred to as master, but now it's sort of like a standard to just call it main. You can rename it as well, but like by default, it's like main or like release branch. Yeah, you have to think of this main or master or release branch as like the final draft, or really the main artery of your like system. So anytime that you are making a branch, you typically make it off of the main branch, because that's sort of like the baseline, the working machine, right? So when you separate your branch, you can do the same thing, just like on other branches, which is like put files into staging, commit them. It's your own little little like mini branch, I guess, that you're able to like save your work. And then when you're done with that work, with that feature or service, or maybe it's the end of the sprint or something, you can push your work back onto the master branch. A typical rule of thumb is you always want master to build. So you don't want to push your code that doesn't work onto the main branch, because you might like uh, complicate some like other workflows, like GitHub Actions or something, or even like the release, that sort of thing. With your small project, you don't really have to like worry too much, but it's a very good habit to get in, is to make sure that your code works when you're merging it. Now, separate branches contain the main branch. Yeah, so they have like the snapshot in time. So for example, your work, we'll just say it's like Gavin's branch is the blue branch here, and Emil's work, which is like someone else's work, or the orange one, they actually start at two different points in time. So the blue branch, or my branch, starts at the beginning of the repo history, which is perfectly fine. And then Emil's branch actually starts about halfway through. So I won't have those two commits that are sort of in the middle, but Emil's branch will. And that's something sort of to get your head wrapped around a little bit. But it's because you're taking like a version of the repo, you're pulling it down to your sort of system, and you're saying, okay, I'm going to work on this feature using this baseline. And then Emil is doing the same thing. And then we end up merging our stuff together. Yeah, this allows you to add work or features or services without affecting anybody else's work at the same time. So if you think about like Google Docs, how I can erase someone's work as they are on it too, that's not really how Git works. It's more of, I have my own copy, I'm typing away, and then I can say, all right, save and push this to the main copy. And Emil's there typing away at his copy, and he's gonna save it and push it to his copy. And then eventually we'll have one master copy of all the paragraphs and sentences that we like typed in. Yeah, and I've sort of mentioned this before. After you're done, you can merge back to main. Yeah. So one big thing that a lot of beginners and even like advanced people struggle with is conflicts. I know I don't like dealing with conflicts when it comes to Git. Sometimes they occur, and it shouldn't be sometimes, it should be more like all the time. All the time they're going to occur. And it's nothing to be scared about. It's best to just like take it one step at a time. Yeah, exactly, all the time. Yeah, so we're actually about to answer, Jamie, your question there. So when two people modify the same lines in a file and then commit it, you can see that you don't know what one to pick, right? It's always the second person who commits that actually gets the conflict. So if I went ahead and changed a piece of code that both me and Emil were working on, I'll go ahead, push it, and then Emil pushes it. It's going to say, okay, wait a minute. Something's funky here. I don't know if I should be thinking about the remote branch, or my branch that I merged onto main, or Emil's. And so Emil is going to have to make that decision on what one to like select, saying like, yes, this is the real version. Conflicts are also like a super last minute, or not last minute, last resort. So Git is actually super smart and can almost determine what is like a conflict and what isn't when it comes to lines. So for example, if I added code that doesn't necessarily like affect Emil's code, it is sometimes able to actually just like push that code together and like almost like stack it, and no conflicts will occur. But other times it won't be if we end up editing like the same variable or something. Yeah. So conflicts is when two commits modify the same portion of code. Yep. And again, it's around like the same portion. It doesn't even have to be like the exact same line or anything. But if you're erasing a bunch of stuff and Emil is adding a bunch of stuff, it's not going to know what stuff to take or go. And again, you decide. To avoid these conflicts, it's best to use lots and lots of files. Don't go like super overboard, but really, really lean into those like solid principles. Which, if you don't know, give it a quick Google. The solid principles and decoupling as much as you can, and committing early and often. Emil talked about this before, but it's really important to commit early, commit as often as you can, even if it's like every 10 lines of code or every session that you sit down, or even like shorter than that, right? You could do every like 2 or 3 lines of code. Stay away from doing like every feature or something. This is because if you have to go back and change your code, or if there's a conflict, when you see the conflicts, it will highlight the lines of code that are conflicting. If you end up waiting like a week and you push code and someone else pushes code, you're going to have all this code that is marked down as red, and it's not going to know what one to pick. So committing early and often and pushing that code too is very, very important in trying to mitigating how much you have to read, reflect on what conflicts you got to like pick. And this is a habit that is very common throughout the industry. So if you're not into that now, it's very good practice to have. As well as long-lived branches. I know that people tend to have branches for like Gavin branch or Emil branch, or even like feature branches too. But you can make more branches for even smaller of features. So even just like initialization of this feature, and then when you're working on this feature, that could be a separate branch. That way, when you have all these branches and they're merging and stuff, it's least likely to have conflicts because you're doing little incremental steps rather than one big step. Yeah, and open close principle. Again, this sort of ties into both of these, but making sure that like the files. Emil, you might have to help me out here for a sec.
Sure.
Yeah.
Yeah, so the open closed, it's kind of like an object. If you're into object-oriented programming, and basically the open closed principle is saying like you don't want to have like a reason to modify existing code. It's like often better to add code. So we can kind of take like forget object-oriented. Like imagine, for example, like having a variable, right? If you had like a magic, you might have heard of like magic numbers or something where you like hard code a value in. If you hard code a value in, then you're basically saying at some point I might need to change it, right? However, instead, imagine you make that hard coded variable, hard coded number, just a variable, and then like maybe you set that variable like when you start up the program or something, or like you configure it through a text file, like or something like that, right? In that case, you're basically saying, yeah, I don't really need to modify this anymore, because if I want to change the number, then I can just like change the settings file or something, right? I don't need to like dig into the source code. So yeah, that's kind of the part there.
Yeah. Awesome. Thank you. I did drop in, this is sort of an aside, but I did drop a link to some solid principles. Yeah, I did see a question in the Q&A. Can we add something to the GitHub repo? Unfortunately, not the one I shared in chat, just that one to clone. But if you have a Git like account, you can feel free to make your own repo, put like a text file in there, and just like practice and play around with things. And don't be scared to try things out. That's how I got relatively comfortable with like conflicts and merging and all that stuff. Awesome. There's one other question here from Jamie again. Is there any standard on branch names, like feature branch name or something like that? No. It really depends on who you are who, like, I guess the project you're working on, the company, maybe your like teammates, that sort of thing. I've been on group projects where people just have their names, and that's like okay-ish, only because you're gonna have big branches. Um, I know me and Emil are actually, or have done group projects together where we do features in those little like incremental, like just like database initialization, and then another one for database stuff, and then another one for like um, database connection, right? And not just have one that's all database.
Mhm.
However, I've worked at some companies where, again, it's just like Gavin. Yeah, it really depends. I suggest either going with features and services, or cutting those up even more, and just doing like sub features or like tasks. That's another good way. Yeah.
Yeah, to
Emil,
jump
do you
in,
which
yeah,
one?
to jump in there, there is like there's a like train of thought of just using completely randomized branch names, like amazing aardvark or something like that, and then like kind of tracking the purpose of that branch elsewhere. The idea there is if you randomize the branch names, then like you never really have to think about it, and you can just have like many branches. The idea there is just to create a bunch of branches that are very short-lived, like maybe a few hours and stuff, and you're like continually like merging it back to main.
Mhm.
So yeah,
Yeah.
I wouldn't advise to start out with that, but
Yeah.
there is kind of no limit of
Yeah.
and no, yeah, so many opinions
Yeah.
on what to do
Once you
there.
start like playing around with Git and stuff, you will start to understand like, okay, this doesn't really work. And like
Mhm.
what does work and doesn't work. And it really depends on the person. Um, yeah. Awesome.
Yeah,
With that, I think Emil is going to show y'all a conflict. Yeah.
sure. Yeah, so here we have our repository. We have this already cloned up. I'm just going to simulate another person working on the same uh, repository. So the first thing I'm going to do is open up another folder and then another Git Bash. And I'll just make sure I'm in that folder. Should exist. Oh, let's see. I don't know why I'm. There we go. So you can see this folder is empty, but what I can do, I'm just going to reclone that repository. Here, see that folder is in there. And so basically, we have on the left-hand side of the screen, person 1, and the right-hand screen, person 2. And so now we're going to simulate a conflict. So the first thing to know is that as of right now, these files are identical. And I can prove that just by going here. That's hello world. And I'm just going to open this up in Notepad to make it a little faster. And you can see it's also hello world. So we talked about how merge conflicts happen when two more people are working on the same file around the same location. And so we're going to kind of simulate a bad like project management and say that, okay, person 1 is tasked with, maybe they're tasked with uh, uh, removing all of those extra exclamation points. They are big on professionalism, and so they are just changing it to 1 exclamation point. I'm going to close this. I'm going to do my commands that we learned about. So I'm going to add the data file. I'm going to commit, and I'm going to say the message is made the data file more professional. And then I'm going to push. And you can see that person 1, no issues. However, if we went to person 2 and we opened, oops, if I can learn how to open this file, we can see that person 2 still has the old copy, right? All with all those exclamation points. So we want to simulate a merge conflict. So what we're going to say is that person 2 was tasked with modifying that same line, but they realized that the person in charge realized that they don't want any capitals. They just want hello world. maybe they don't want this either. So 2 people got different tasks. I'll even add some other things like today was snowy. Today was snowy won't really cause an issue, but I'm just adding more changes for the fun of it. So person 2 did some work, saved it, close it. They think, okay, everything's okay. So they go ahead and add the data file, which is not going every time. Okay, so I'm in the repository now, and then I'm going to do git add the data file. That is fine. I can even commit. And I said lowercase everything and removed comma. Good message. So it's committed. It's in my local repository. And then they go ahead and use git push. And you can see some red. So the thing with Git is that you'll notice they give you a lot of hints. So I do recommend reading through them. And even if you don't really understand the terms sometimes they use, like refs or whatever, do read it, and you'll at the very least you'll find something to Google, which is always nice. And you can see there's a hint here. It said maybe try git pull before pushing again. So we're going to try that. We're going to try git pull. And you'll notice the one thing is that there isn't any red, but there is a huge conflict. There really should be red here. And what it's saying is that you need to fix the conflicts and then commit the result. So what that means is, very simply, is basically the data file that was that we try to update, it's kind of in the state of flux. You can see that even Git is saying, oh, you're now in a merging state. And if I open this text file, which I am struggling to do again, we can see that this text file looks a lot different than what we wanted it to. You can see that there's this little thing called head and all that. So, and then you can see another kind of squiggly brackets with that. The way to read this is to say that, and really find these set of equal signs, and basically just think that this part between the equal signs and this alligator brace head, that's kind of the changes you have. And then down here, this is the changes that are on the remote repository. So if I go to the remote repository, this is what this is kind of what exists on the repository. You notice it's even like a B13, like this is just an identifier. And if I go back here, you can see that same B13 stuff with a lot more characters. So basically it's saying, this is what GitHub has, this is what you have. I don't know what to do because it happened around the same time, same lines, and it is quite different. So the thing to note about Git merging is that to resolve the conflict, you need to know what the project is trying to do, right? So this would be a time for person 2 to maybe call person 1 and say hey, what are we trying to do? What did the boss tell you to do? And person 1 might say, well, the boss told me to change all the exclamation points just to be 1. And then person 2 can be like, cool, because the boss told me to lowercase everything. So if I was to try to combine these 2 tasks together, really check with your boss if they're giving tasks that are crazy like this, but also to realize that maybe what the boss wants is just 1 exclamation point with everything lowercase and no comments. So we can do that. We can just erase all of this, erase all of that, and get rid of all of the exclamation points, and we're good. And so to resolve the conflict, you get the files to look like what you want it to look like. So you merge it yourself. Now before I step away, I'm just going to copy this and then put it in a new window to keep later. But yeah, we'll repeat all of these changes. So everything's lowercase, 1 exclamation point. I save it, and I'll get rid of that extra line, and everything is good. I can close it. And then, so I fix the conflicts, and then Git tells me to then commit the results. So to commit the results, we just have to repeat our typical process. So git add file, git commit, and say like resolved conflict. And then I can do git push, and you can see everything is good, right? And then meanwhile, on this side, I can run git pull, and you can see that it's getting the changes as well. And then on GitHub, I can see that it is what I want it to be. So the key takeaways to note is that the merge conflict happened because there was kind of like an ambiguity in the tasks, and the tasks kind of overlapped in what they were trying to do. And that to resolve the merge conflict, I just get the files to look like what I want it to look like. And that might depend on like checking in with other team members or like really thinking about what the project is trying to achieve. And yeah, so that's a merge conflict.
Awesome. Thank you, Emil. Yeah, that was a very simple merge conflict. They oftentimes won't be that simple, but I just suggest like calling up the other person, taking a deep breath, and just like going through sort of like the files and stuff like that. Yeah. So GitHub, I know we sort of sprinkled it throughout the presentation here, but it's a very popular remote repository manager, as you probably heard of before. There's lots of advanced tools that we're not covering today, unfortunately, but it is a place that you can share and organize your code. There's also like project management features. You can view the branches, merge code through GitHub as well. Look at older versions, track issues and changes. So it's a very, very powerful tool. And if you haven't sort of made a repo and just like played around already, I suggest you do. Even just like a private repo and seeing what like projects and like the wiki looks like, and even like what security tools you have and that sort of thing. Some alternatives you may run into is Microsoft Azure, which if you're a Conestoga student, you probably have access to. And it's pretty much the same thing as GitHub. I'm pretty sure Azure is actually a wrapper for GitHub. Yeah, so it has most of those features and everything. But Bitbucket is another big one that a lot of like major companies use because it's more like privatized and that sort of thing. So yeah, that is another thing. But all the Git commands and everything is the exact same. Yeah.
Mm-hmm. And even the thing you download, like Git, the software works with all of these. So
Yeah, exactly. Yeah. So Git is the software or like the framework that you use to do all this stuff, while GitHub is like omitting the name. It's the place that you like push your stuff into. They're actually two separate entities. And same thing with like Azure and Bitbucket is like they're two separate things. Yeah. Awesome. So you've seen Emil use the Git Bash, but there is a plethora of other tools that you. Oh, sorry, my little light thing for my camera started flashing. Yeah, so Visual Studio Code has some really awesome tools and extensions. They have one that's already built in that does pretty much everything that we've talked about: the pulling, the pushing. The committing, the staging, all that stuff. But there's also Git Kraken as well, which if you are a student, not just at Conestoga, at any other school, you can sign up for GitHub Student Pack. I believe that's what it's called. We do have a link here. And this student pack gets you Git Kraken for like a year or something, or maybe during your time of school. But there's tons of other things like free like DigitalOcean credits and other softwares and stuff. Highly recommend you just like get it and see what you use pretty much. Yeah, exactly. You get a lot of benefits. Yeah. Emil, I think, is going to show us the source control in VS Code.
Yes. What I'm going to do is just reopen this text file in Notepad and then get my old changes into it to kind of redo the merge conflict. Then I'll open up in VS Code and show you like what VS Code can do. So the first thing is, yeah, so what you can see here is we have VS Code open. And you can see that when you're in a merge conflict, it'll give you this nice highlighting. That's kind of the thing I wanted to show. And it even gives you these like convenient buttons. So say if I just wanted this, I can just click that button and then it'll do all of that. Or if I just wanted the incoming changes, like the changes from the repository, I can do that. But yeah. The other thing that's maybe more specific to Git is the source control pane. This might not appear. If not, you can go to view and then source control, and it'll bring you to the same thing. And you can see that if I made changes, so say if I say instead of today snowy, I could say like, today was really sunny, and I hit save. VS Code will detect that change, and then you can do things like that plus is like git add. I can commit it, I can push it. One thing I really like is if you just double click the file, it'll show you it'll highlight like the specific changes, like maybe not as visible, but like it'll show you like not just the line that's changed, but it'll even like kind of try to subtly show you what in that line has changed. So it's very, very useful. Next tool, I don't know if you talked about it, the GitHub desktop. I can just
No, I haven't. But
launch
yeah,
the.
so GitHub has its own like desktop software that is like a mini GitHub in it. Yeah, you're able to do pretty much all the same stuff as the like Git Bash and this, just in like a GitHub friendly environment here.
Mhm. Yeah, and you can see that you can like look over the history. You can even pick branches to compare. There's like a lot of
Yeah,
stuff.
useful tools and stuff.
Yeah,
Awesome.
awesome. I'll head back
Cool. Okay.
over. Yeah, there we
Yeah.
go.
If you use Visual Studio 2022 or like 2019 or whatever, they also have the same thing. It's very similar to like Visual Studio Code. It's called like the Remote Explorer. But I think me and Emil both really insist that you play around with Git Bash first, just to try and get used to the process, because you'll spend a surprising amount of time going back to the terminal and everything. And so you should sort of like know how to work your way around that before you move to other tools.
Yeah, and then I think I'll just add on is you can definitely mix and match stuff. So what will kind of often happen with me, at least, is I'll be using like the visual stuff because I'm kind of lazy, and I'll be going through, and then I'll reach a situation that like is unusual, I guess. And in those cases, sometimes it's nice to just open a terminal up and then, or like open Git Bash up and then work, finish kind of my work through Git Bash to kind of like resolve the situation or whatever. Just because you kind of have a bit more control over what's
Yeah.
going on.
Yeah, I second that a
Yeah.
lot. Awesome. Now, I think we definitely do have some questions in the chat here. I've been sort of answering them, but I think it's good to get Emil's take on this stuff. So one
Sure.
of the questions was, how can we restrict a type of file in order not to submit to a remote repo?
Oh, that is
Yeah,
such a good question.
yeah, it is a
Um,
good question.
and maybe it is something for like a later
Mhm.
tutorial. But so if you have like types of files that so the first thing I'll say is that you will often run into a situation where there are some files you don't want to commit, and you could just rely on telling everyone to not use git add on it. But with something like a visual tool, what will often happen is people will just click this button, which is just push everything up, and then you deal with the rest. So in those situations, what you'll want to do is create a file called a Git Ignore file. So something like well, first it's .git ignore, and then this git ignore file will kind of specify types of files not that you shouldn't commit. So I'll give an example. I'll open this folder up in the VS Code. I'm just using VS Code to make it a little easier. And the one thing is with Windows, it loves putting the .text extension on everything, so get rid of that. And say there's a file, like maybe I'm writing Python for some reason, but I don't want to, I don't commit Python. So I do blah, 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 blah. You can see that VS Code is itching to commit it, but you don't want to. Your git ignore could defines files to exclude. So, and it works through a thing called globbing. So it's the one thing to note about Git is that it was created by Linus Torvalds, who develops Linux. So everything Git does is very Linux or Unix inspired. But basically you can put an asterisk and then like a .py. This asterisk just kind of means like, catch all. So basically it's saying any file with any name that just ends in .py, ignore it. And you can see here that it's first grayed out. And then if I go back here, it's not visible there. Now, there is a kind of a unique situation. Well, what if you committed a file and then you want to, kind of scrub it from the repository and never ignore it again, and never commit it again? That's another topic, and my advice is just Google it. I've run into it a few times, but each time I just Google it, and then there is like a string of commands that you can type in to kind of scrub the repository of a file and then continue to ignore it. But it's kind of a unique situation. But yeah, in general, set up a good git ignore when you start a project and like early on, and try to avoid committing stuff that you don't want to.
Yeah.
And you do use the git ignore, and make sure that you also commit the git ignore so that other people who are working on the project can get it, and so they also ignore the same files. So it's very important to do that as well. Yeah.
Awesome. There is a lot of conversation going on in the chat. What is the maximum file size supported by GitHub? I believe it's 100 megabytes. However, if you do have something that is bigger, you can use this thing called large file storage. I played around with it before. It's a very interesting concept. It creates like a pointer to the file where it's needed in order to get around like using it. So you have the file on your computer, and then you like push it. And with that large file system, that doesn't get pushed, but like pointers to the file, so it can still like build and stuff. I believe that's how it works. But yeah, check that stuff out if you need something that is bigger than 100 megabytes. More often than not, it is hard, very difficult to get above that 100 megabytes. But yeah, awesome.
Yeah.
Yeah.
Sorry to just add on to it. Another method is to just think of a different way of getting large files to and from people. So like if it's like, for example, if it's like something that could maybe be a Docker image, then put it in there. Or if you can like write a script that like downloads from Google Docs or Google Drive, or maybe from like, say you're like working with like, I don't know, a big file that often comes up as like ISOs. Maybe you can like just find the URL of that ISO and then put a little script that downloads it. So there's always another option too.
If we involved a .env file in Git Ignore for privacy reasons, which contain all the sensitive data like database link and all, so how do we host? I mean, there will be no environment in the repo, but we want to host the whole repo. So this is interesting, and I think it's more of a system design sort of thing. But Amelia might be able to like talk about this more. So in my mind, is what you'd be doing is for that environment, you want to not host it from GitHub, but instead have like a system, like another server or something, that you that you want to host it on that has the .env. But yeah, I know that there's a lot of conversation here that I'm going to
Yeah.
read. But Emil, do you have anything to add to that?
Sure, yeah. So a good rule of thumb that you'll generally see is to never publish or never push private information or sensitive information to a repo. Now you might say, well, what if the repo's like secret or private, right? Like you're gonna have private repos on GitHub. Yes, like that could work, but your only line of defense is it being private. And like if you think of the data, like it's not encrypted on GitHub server. So to get around that, another way is there are a lot of like password manager team things. So one I know of is Passbolt, which I think is more meant for like people to use to copy and paste. And another one is like HashiCorp Vault. I haven't used any of these. But you can see like HashiCorp Vault also integrates with GitHub too. So like, and you can see why. So basically it'll be, if you want to look at like managing secrets, you want to look into looking at another service to do it. Or like if say you're just wanting like a database to test with, you could look at something like Docker so that you can host the database locally on your computer. And in that case, like it doesn't really matter because it's just like a temporary database. But that's a very good question, right? And if
Yeah.
you think back, like earlier, I talked about like how you can use like Ansible and Terraform to manage stuff. Ansible, for example, has its own secret management thing where it encrypts the data, and that's because they know that you'll often use Ansible with Git, and they know that Git doesn't really provide any like secret management for you.
Mhm.
But yeah, really good question.
Yeah. Yeah. There is another question. Can you give some information on Git pipes? I know it's an advanced topic, but still, if you can, and this is definitely an Emil topic.
First thing I'm going to do is type in, like, are we talking about like pipelines?
I'm gonna assume yes.
Yes. So you might hear about like CI. I'm going to guess we're talking about CI/CD pipelines. I don't have the chat open, so if that's not it, please let Gavin know and he can tell me.
Yes.
Um, but yeah, so when the big trend with Git now is a thing called pipelines, or like kind of like automation things. And basically the idea is as you're pushing commits to Git, right? You want your like remote repo to like maybe build the project for you or run tests. And this often will use something like a pipeline. Though pipelines is kind of a specific term. So like GitLab specifically uses the word pipeline. And I think there's like maybe Bitbucket would also use pipelines too, if I remember.
Yeah. Yeah. Yeah.
GitHub, for example, uses a thing called actions, which are very, very similar, but not the same. Or like it's very similar, but it's just not the same name. And basically what these pipelines are, you can think of them as like very simple scripts that do things. And don't like, it's a very good question to ask because it's very important to, like, it's a very useful thing. So for example, I can bring up a project I had last term. So I'm talking about actions, but it's the same thing. But basically, we can do things like we had a Python project, and so I had a action or like a pipeline thing that just ran unit tests. Similarly, like this is more of a real pipeline. I had a thing where it's sets up like the Python environment, it builds the application, and then it publishes it to PyPy, and then it builds an image. So you can think of it like as a, and the reason why we often use the word pipeline is because there's like an input, which is like the first input is your source code or whatever's on GitHub. And then you'll have like different processes and scripts and stuff that, maybe at the end of one pipe is like executable, like binary file. And then the next pipe will take that like application, like that binary application, and then it'll package it into, or like it will, make it, publish it to like a web server so that people can download it from. So yeah, very good question. I probably shouldn't talk more about it because it is a whole kind of worms.
Yeah.
But it is like as you get comfortable with Git and GitHub, do look into that kind of pipeline or CI/CD stuff, because it's that level of automation is becoming very popular,
Mhm.
for sure.
And we sort of plan on hopefully having maybe one or two more of these like Git and GitHub sessions to sort of focus on those like more advanced things, such as like pull requests, like projects, wikis, that sort of thing, and also something on actions as well. And maybe even like bring a speaker or something too on that stuff. So look out for that. Awesome. Do you mind going back to the last slide there, Neil?
Sure.
Yeah. So if there is any other questions, feel free to post in the chat or in the Q&A. But we do have a feedback form with a little raffle as well. You can scan it, or I posted a link in the chat. It's pretty short. I think there's maybe 2 questions that you have to like type some stuff out. But yeah, the prizes of the raffle is a shirt. You get a GDSC like sticky note pad, which is actually really really cool. I don't know why I like them so much, but also a very fancy and sort of rare GitHub Octocat sticker, which I have been keeping for this exact event for like 7 months. um, but
Sorry.
yeah,
Cool.
as you all do that, there's another question here. How do you clone a repo when you have multiple Git accounts in the same computer?
Oh,
Um, I think you can still do it, right? But it might become a little bit of a funky thing when you're trying to like push your code, because I don't know exactly how you like configure. Um,
yeah, that's a good question.
yeah, do you know what I mean?
Yeah, I would imagine, I'm not 100%, but I would imagine that if, say, you had an Azure account and a GitHub account, you probably won't need to worry because Git should be able to figure out, Git should be able to figure out, handle multiple credentials, and it should be able to figure out which one to use.
Mhm.
Um,
I see. So they added there is a config file in the .ssh.
oh, yeah, so I was going to get into that as well. Um, I'll leave this up, but basically Git has 2 ways of authenticating. It can authenticate over HTTPS, which basically means that it kind of communicates kind of like a web browser, a web server kind of approach. It's the same protocol. And there, I believe it uses the typical web authentication stuff. So like you log in, username and password, and then it gives you like a cookie or a token or something that you save. And then when you try to push and stuff, GitHub knows to use that cookie, whatever. What you're talking about with SSH, that's the other way that Git can configure itself. And so if you don't know what SSH is, it's basically a way to get like a command line prompt on other computers. It's very big on Linux, which Git also is a Linux centric project. So that's why they work well with each other. And in that case, you probably would, if say that probably would allow you to have, say, 2 GitHub accounts that are working on different things. And in that situation, what you can do is create, like, I'm going to just kind of give it a high level. Basically, you want to create a SSH key pair. So you'll have like your private key, which you can think of as a password, and a public key. And you can think of that as something that you like kind of copy and paste onto GitHub to authenticate. I'll quickly go over and show you. So if I go to my GitHub and then go to settings and then go to SSH and GPG keys, you can see that I have a SSH key on here, and I can add a new one. So maybe
Uh,
I could like,
Wait, sorry, you're not
Mhm.
sharing. You're sharing a screen. It's still the PowerPoint there.
It's still the PowerPoint. Oh my gosh. um,
All good. The link's in the chat, by the way, if you still need it.
cool. Yeah, so can you see my screen now on GitHub?
No.
Really?
Maybe stop sharing and then reshare.
Just reshare entire screen. There we go.
Yeah.
Cool. Because it's like showing that
There
I'm
you go.
sharing it. Yeah.
There you go.
Okay.
Yeah.
So to get to this page, I went to settings and then I went to SSH and GPG keys. And you see that I already have a SSH key added, but I could add a new one. I could like log out and log back into a different account and then add a different key for a different account, probably. Or even, yeah, probably I would want to, you would probably want different SSH keys for different accounts. The one thing I would say is that GitHub, and I can't say for other platforms, but GitHub in particular has been getting better at letting you have multiple identities. Basically, they have this idea of an organization, and I've played around with this a bit. But basically, what a GitHub organization is kind of like a different identity. But like you create an organization to like manage a group. So for example, like Google has a Google GitHub organization, that thing. So in that case, you know, when you create repositories and push and pull, like it's still under your private account, but the repository itself is owned by different accounts. So I just brought that up because it's kind of related and kind of can get you to a similar goal. But otherwise, if you just have two GitHub accounts, your best option is to try to make multiple SSH keys and then add them to your account and then look into the SSH config, which you mentioned. The SSH config file is basically a way to tell which SSH key to use for what. Though, from what I understand, it's not a good practice to have multiple GitHub accounts, probably. But
Yeah.
I'm not 100% sure.
Yeah, if you do have, so what I do is I have like my main GitHub account that has like my student email, because if you sign up with your student email, you're able to get the like other student perks and stuff, and it links the two, which is really nice. And then when I graduate, I plan just to like swap that out. So
Yeah.
that's what I recommend doing, because you don't necessarily want multiple accounts, or like it's kind of annoying on a project if there's like two Emils or like two Gavins. One's my student, one's like my personal one or something. So yeah.
Yeah.
Also, Jamie, you talked about, and I think you have to add the account you want to use to clone in git clone command, like git clone dot 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 at my user. Not necessarily. It should just be the dot git. So if Emil, we go to, yeah, just like any, if you click this
Yeah.
code, it will be that exact link over one. Yeah, that guy right there.
Yeah.
But if you're specifically talking about the SSH stuff, it
So
will
yeah.
it will look like that at symbol and that sort of thing.
Yeah, the thing to note with SSH is that GitHub uses SSH a little weirdly, um, as in they only have, uh, like you see that it pre-filled git at github.com, right? So you don't actually use your like username. It's always git clone git at github.com, and basically it'll use the SSH key to figure out which identity you want to clone as. So, and I could Google this a bit more, but from what I understand, if you have two GitHub accounts, it might be a manual process of like tweaking your SSH config to set it to a different key when you want to be one account, and then tweaking it again to be a different key when you want to change that account. Um, I would say there is a thing called a Git credential manager. That could be like Git credential managers are like things that go on top of Git that like kind of automate some of this like credential stuff for you. I don't really use it much, but like investigating that could be another option.
Mhm.
Um, okay, so
So, sorry, two more questions here. Um, you can have multiple emails added. You can have multiple emails added to the same GitHub. Yeah, so you can like send invites to your friends and stuff. If that's sort of answering your question. But if it's just for your personal thing, you can, yeah, okay, there you go.
Yeah.
Emil has both. Yeah, awesome. So Jamie is also adding, but what if you had your personal and your company's Git? So I think I'm starting to understand your question. If you'll use the same computer for both like your personal and your company, but your company uses like your company credentials, so like Gavin at company.com, and your own credentials. So like Gavin at Conestoga.com or whatever. How
Mhm.
I think your question is like, how do you like differentiate the two in like the Bash or maybe in like VS Code or something? Uh, any thoughts there, Neil?
Oh, for me, um, yeah. So say if you had two emails associated with the account, like a personal one and a company one, you could like go to git config and change the email that's being used.
Mhm.
And so that will
Yeah,
uh, that
I
will like,
think
yeah. I think if
yeah,
that's what he's getting
it's
at.
a very like tricky question, and maybe we don't fully 100% know. I think in Visual Studio like 2022, um, when you like have a repo, you can like set that specific project up with like an account, um, I believe. Um, but yeah, I'm not exactly too sure.
Yeah,
But awesome.
there is a link about managing multiple accounts, so you can look into that. But you like from like from people I know and like kind of just generally, usually people will just have one account and it'll be for their personal stuff and they'll also have their work stuff. Um, they'll have an organ. So this is a GitHub organization for Let's Encrypt, and you can see it's an organization. So it's kind of like a user. It has repositories associated with it, but nobody commits as Let's Encrypt. Instead, they have a bunch of people, or 4 people, I guess, who are part of this organization. And so presumably these people will have like a personal and a company email. Um, and they will commit these repositories, but none of these people own the repository. It's the organization that does,
Mhm.
um, or like the
Yeah,
organization account.
and I think it will be sort of on your company to determine like what you can do. Um, Yeah, oftentimes also like companies will give you a computer or something, or like a VPN into some like remote desktop or something. So
Yeah,
yeah,
at my last company, they gave me an account, or they gave me a laptop, and it was a completely separate account.
yeah,
That was like internal.
yeah, yeah.
So
Awesome, cool. I think that's it for today. Thank you everybody for coming. I think that this session went super well. Um, if you haven't already, fill out that feedback form. I will post it in the chat again. Um, But yeah, thank you so much. Hopefully, see you next time. We also have an event tomorrow for the Ideathon for Google Solution Challenge as well. You should come. I think that would be super fun. You get to meet more people, talk, start thinking of like ideas for projects and everything like that. But yeah,
yeah, yeah.
thank you. Yeah, you're
Thank
welcome.
you.
And thank you, Emil, for typing and everything too.
No
Yeah.
worries. um, yeah, I'm glad it worked well. I'm glad people found it useful. And if you have like further questions later on, you can always drop them into the GDSC Conestoga chat, and we will try our best to answer.
Mhm.
But
Someone asked, is it still happening tomorrow because of the storm warning? I'm not exactly sure. I'm going to say yes. If anything, we'll just like push it to like online. It is a virtual
mhm,
event, or sorry, it is a hybrid event. So there is like in person and virtual. So like worst comes to worst, we'll just like move it all to virtual or whatever.
virtual, yeah.
Yeah,
Cool.
cool. Okay, thank you everybody for coming. Enjoy
Awesome.
enjoy your night.
Thank you.
Thanks.
Alrighty.
Bye.
Bye.
Bye.